Continuing with section 2, talking about rectilinear motions, projectile motion. We said an object that is dropped, thrown, or fired, and we had the height. In general, it is given by that formula. We have got an example. Let's start to analyze that example. It's a word problem. You have to solve that word problem. A person is standing at the top of a building 112 feet high, throws a ball vertically upward with an initial velocity 96 feet per second. So what do we have? We have got a person at the top of a building. The building is 112 feet high. And what's that person doing? He's throwing a ball upward, okay? So he's throwing it up like that, vertically upward, with an initial velocity, and gives him an initial velocity of 96 feet per second square. Let's draw that man here, okay? It would be better for you to draw him so that you would do calculations better, you will see the things better and nicer. So we have got here, and that's the ground, okay? We have got a man standing here on the top of a building. That is a building that we have got. Okay, that one is on the top of the building. We have got the height of the building is equal to, it is given to us, the height of the building is 112. So here, that height from there to here is equal to 112. That's what? That is h naught. Okay, that's the initial height is given to us. What's that man doing? He's throwing a ball. Okay, he has got a ball in his hand and he is throwing a ball vertically upward. Okay, so that ball will go like that and come down, of course, like that. The ball will not stay at the top, of course, it will definitely get down. What is the initial velocity of that object? Because that man is throwing the ball upwards at an initial velocity of 96 feet per second. So initial velocity, okay, v naught, that's initial velocity, that's equal to 96. It's giving a little bit velocity to the object, and that is 96. We have got initial height and we have got initial velocity. It's required from us, the first requirement, it says find the ball's height and velocity. Okay, height gt, okay, and velocity at time t. So in general, it's required from you to find the height and the velocity at time t. If you remember, or if you just look back, the height in general is given by this formula. Okay, so it is easy. You just know the formula and you're done with the first requirement. So h of t is equal to what? Is equal to minus 1 over 2 gt squared plus v naught multiplied 2t plus h naught. Let's put those values that we have got. We know that g is equal to 32, so that will be minus 1 over 2 multiplied to 32. It's required for me to find it at time t, so the t in here is general. I will write it as it is. Plus v naught is equal to 96. Okay, that's the initial velocity, multiplied to t is in general again, plus 112, because h naught is 112. Let's simplify this one more. We get this one cancels with this one, that will be minus 16t squared plus 96t plus 112. So that is the height of the ball at time t, at any t. For example, you calculate after 3 seconds, you will get the height after 3 seconds. You calculate it after 10 seconds, you will get the height after 10 seconds, and so on. Okay, so that is in general. How about the velocity? Velocity is what? Velocity is the change of position. H, the height, is the position that is given to us in here. So that would be the derivative of h at time t. Okay? So what is the derivative of that h? If I take the derivative of this one, that will be minus 32t plus 96 and plus 0. Of course, I will not write it here, okay? Because that 2 is coming down here, it will make it minus 32t plus this one is equal to 96. So the first requirement is what? Is the height and velocity in general. We are inputting the values that are given to us initially, and we will get the general idea for height and the velocity of that object. Okay, 233. The second requirement, it says, when does the ball hit the ground? What does that mean? If you look at that one, it is required from you to find the time, okay? When that means you are searching for t. T is equal to what? When does the ball hit the ground? The ball hits the ground when it comes here, okay? It's hitting the ground. When it is hitting the ground, what comes to your mind? What is the velocity? What is the height? What is the time? Of course, it's searching. We are searching for time. If you look at here, if the ball hits the ground here, that means the height of that object is equal to what? Is equal to 0. Okay, so we are having this one, this equation, that's h of t is equal to that equation. It's required from us to find t, and that h is given to us as it is hitting the ground, and that's equal to 0. So how do we calculate it? Simply, we will say that h of t, let me write the equation first, is equal to minus 16t squared plus 96t plus 112. The ball hits the ground, that means h is equal to 0. So 0 is equal to minus 16t squared plus 96t plus 112. That's a quadratic equation. We can easily solve it. First, you can take negative 16 out. Of course, to make this quadratic equation simpler to solve, it's better to take that minus 16 out as a factor. Okay, so that would be minus 16t squared leaves alone here. We took out a negative sign, so that positive will be negative, that positive will be negative. 16 out of 96 is 6, because 6 multiplied to 16 is equal to 96, and 112, if you take 16 out of it as a factor, 7 will remain, because 7 multiplied to 16 is equal to 112. Okay, let's solve that one. I'm dividing both sides by negative 16 to get rid of that one. So that will be 0 equal to 2 squared minus 60 minus 7. That's an equation to be solved. So t here, t there, 7 here, 1 there. Which one is negative? The 7 is negative, the 1 is positive, because minus 7 multiplied to 1 is equal to negative 7. And if you add them, you get negative 6 in here. So from here, we get that t is equal to 7, and from that bit, we get that t is equal to negative 1. Can I have time as negative? No, so that will be neglected. Okay, or we cross out that value, because t cannot be negative, that's time. So when will the ball hit the ground? That means at what time the ball will come to the ground? The ball will hit the ground after 7 seconds. Okay, so when that man is throwing that ball, it will come to the ground after 7 seconds. So that is 7 seconds. The other requirement, it says, when is the velocity 0? When, again, t is required from us, the velocity is equal to 0. So here we have got v is equal to 0. In the first requirement, height and velocity was required from us at time t. So velocity is equal to v of t. let me write the general formula of the velocity in general. That's equal to minus 32t plus 96. Okay, it says v is equal to 0, find time t. So that v is 0. 0 is equal to minus 32t plus 96. That's an easy equation to solve. We are taking that 32 to the other side. That would be 32t equal to 96. Divide both sides by 32 because we're searching for time. T is equal to 3. Okay, seconds. So the velocity is equal to 0 after 3 seconds. If you imagine throwing a ball like that, okay, the velocity becomes 0 at the peak. Okay, so here is the peak, and here velocity is equal to 0. Why here velocity is equal to 0? When we threw the ball, it was 96. Sorry, the initial velocity was 96. So how would the velocity equal to 0? Because when you're throwing that ball up, the gravitational force affects that velocity. Of course, it will change it to 0 and then decrease the velocity so that it comes to the ground. Okay, so the velocity is diverged. Of course, if there's no gravitational force, that velocity will not equal to 0 and the ball will just go up because you've given the ball an initial velocity of 96. But the gravitational force changed it to 0. So what is the t here? Okay, at that point, t is equal to 3. After 3 seconds of throwing the ball, the velocity will equal to 0. The last requirement, it says how far does the ball travel during its flight. So it's required from us to find the traveling period, traveling position of the object that we have got. What's traveling period? It's starting from here. Of course, it says during its flight. It doesn't say count this part also. So it's required from us to check that position from here to there till it touches the ground. Okay, we have to find that length. What's that length? That length is equal to what? Is equal to that height. Okay, that height plus this height. Okay, that's h tall, h small. Okay, if we know that height plus that bit, we can get the traveling period or traveling length. Okay, travel length of the ball. How do we find this bit and that bit? Well, that's easy to find that height. How do we find it? We know that t is equal to 3. When the ball reaches here, t is equal to 3. So if we put that 3 into the height equation, we can get that value. So the first thing that we have to do is to find h of 3. h of 3 is equal to what? It's equal to, where is the formula? It's minus 16 multiplied to 3 squared plus 96 multiplied to 3 plus 112. That's equal to what? If you calculate it with a calculator, that's equal to 256. Okay, so that height is equal to what? That height is equal to 256 that we found now. How about this small height is equal to what? We know that this the height of that building is 112. If I subtract 112 from 256, I will get that bit of height. Okay, so that was the height, as I called it height, the tallest height, the longest, not the tallest one. Okay, the height of the small part is equal to what? Is equal to 256 minus 112. 256 minus 112 is equal to what? That's equal to 144. So that bit is equal to what? 144. So this piece we found is equal to 256, and that bit is equal to 144, is equal to, so we can find the travel length as what? As edge of, as I call it from there, tall plus the small edge. That's equal to 256 plus 144, and that's equal to 400. So the travel period, the travel length of that ball, let me here, it traveled from here till down there, is equal to 400 feet. That's all about that rectilinear motion and a projectile motion. You just need to know that that edge is always something constant. You have to know that formula. It's also given in the material that you have got. And the velocity is equal to the derivative of that height, because we said the derivative is the velocity is equal to the rate of change of that function that we have got. You have to know that g is the gravitational force, v naught is the initial velocity, and h naught is the initial height. And that's all for that section. I hope when you're watching that video you would understand everything well. Bye for now.